In this video, we're going to learn about some of the glands and hormones involved in homeostasis. Glands are organs or tissues that produce a secretion or product that acts somewhere else on the body. And there's two different types of glands. One of them are exocrine glands, and exocrine glands have ducts that send their product into another target organ or tissue, and endocrine glands don't have ducts, so they send their product, which are now known as hormones, through the bloodstream. So some examples of some exocrine glands would be, the stomach, the liver, the gallbladder. They all have ducts that would secrete their product. And endocrine glands would be parts of the pancreas, the parts that are involved in blood sugar balance, and then reproductive glands, the hypothalamus, and so on. Now, there are three different types of hormones. The first type are steroid hormones, so they are steroid derivatives. So an example would be progesterone, and the source would be the ovary or the placenta, and the target of the action, if it's on the uterus, and it maintains pregnancy or regulates the thickness of the endometrial tissue. Another type of hormone are protein hormones. So an example would be leptin. So leptin is a protein, and its source is adipose tissue, and its target would be the hypothalamus. So the adipose tissue will release leptin and act on the hypothalamus to signal that the body has eaten enough, and then your appetite would decrease. And then the last type of hormone are tyrosine derivatives, and an example of this would be the thyroid hormones, and the source is the thyroid glands, and the action would be many targets. So it would determine your baseline metabolic rate, the amount of thyroid hormones you're releasing. The pancreas is actually two glands combined, so it does have an exocrine portion, and the exocrine portion produces the digestive enzymes that help break down our food, and its target would be the small intestine. So, pancreatic lipase, pancreatic amylase, and so on would be produced in the exocrine portion and then released into the small intestine to break down our food. The second portion is the endocrine portion, and it produces hormones involved in blood sugar balance, and those two hormones' names are insulin and glucagon. Now, you can see here, this part along here is the duct. So all the exocrine products would be entering the duct, the enzymes would enter that duct and head off to the small intestine to act on the target tissue. And then these little clusters of cells that look like little blobs are the islets of Langerhans, and that's where the endocrine portion of the glands are. The center part is red, and that would be a blood vessel. So all these cells surrounding the blood vessel are producing the hormone, whether it's insulin and glucagon, and then releasing it into the bloodstream in those islets of Langerhans. So they look like little islands in the middle of this pancreatic sea. So glucagon is released by alpha cells in the islets of Langerhans when blood glucose levels are low. And glucagon causes the liver to convert glycogen to glucose, and ultimately the blood sugar levels will start to rise again. So glucagon is released when blood glucose is low and causes blood glucose to rise. Insulin is released by beta cells when the blood glucose levels are high, and insulin causes the liver to convert glucose to glycogen, so to store up that excess glucose. It also helps cells in receiving glucose so that they can perform cellular respiration, and this will cause the blood glucose levels to drop. Diabetes mellitus is a chronic disease, and in this, depending on the type, either the body can't make insulin anymore, or the cells have become insulin resistant in the body, and ultimately, no matter what type of diabetes mellitus it is, it causes hyperglycemia. And that means that the cells can't get the glucose they need because it's staying in the bloodstream. So there's three types. The first type is type 1. And in this case, due to some autoimmune attack, the beta cells have degenerated. So now there aren't any beta cells. They can't produce insulin because they aren't there. And there is no insulin, so the person must take insulin for survival so that they can use the glucose that's entering their body. Type 2 diabetes usually shows up later in life, and it's due to some lifestyle choices, not eating the proper diet, a variety of genetic causes, and so on. And these people either make too little insulin or their cells are resistant to the insulin that they are producing. So the treatment plan for this would be to adjust your diet, to exercise, and you may need also to take a drug called sulfonamides to help maintain your blood glucose levels. Gestational diabetes is very unique, and it happens in pregnancy to the mother, but disappears right after birth. And it actually occurs in 2 to 4% of pregnancies. And the mom and the baby who have undergone gestational diabetes are then at greater risk of developing diabetes later in life. And if untreated, the baby tends to be a larger birth weight than normal because they have been supplied with excess glucose because of the high glucose levels in the mother's body. The thyroid gland is a gland at the base of the neck, just in front of the trachea, and it almost looks like a little butterfly. So it's this gland right here. It's a two-lobed gland, and it makes thyroxine, which is a hormone involved in metabolism. Thyroxine is the hormone that is involved in raising our metabolic rate by causing our cells to increase sugar utilization. Iodine is required for producing this hormone, so if there's not enough dietary iodine, you can develop what is known as a goiter, which is an overgrowth of the thyroid gland. This is actually a mild goiter. Sometimes goiters can be very, very large and be protruding from your neck, and you would have a huge bulbous growth from your neck. Because we don't want to develop a goiter, we actually add iodine to our salt. So if you read a label on a box of salt, it says that it's iodized salt. So iodine is added just to be ensure that we have enough dietary iodine. So the control of the thyroid hormone is a negative feedback loop. And remember that negative feedback loops resist change. So if the thyroxine levels have dropped in the blood, the hypothalamus will release TRH, which is thyroid releasing hormone, to the pituitary. The pituitary then will release TSH, thyroid stimulating hormone, to the thyroid, and then the thyroid will release more hypothyroxine. The presence of thyroxine in the blood then causes the hypothalamus to stop releasing TRH until the levels drop again, and then the hypothalamus will release TRH and the loop will begin again. Hyperthyroidism is when excess amounts of the thyroid hormones are produced, so a person's metabolic rate would be much faster than normal. And people with hyperthyroidism are usually very warm. They can lose up to 60% of their energy as heat instead of usable energy. And the symptoms would be having a high temperature, fidgety behavior, and weight loss, among others. The reason why would be the gland was either overstimulated through too much releasing hormones or stimulating hormones being produced, or through an overgrowth of the gland. So a treatment would be to possibly remove part of the gland so that you're not producing so much thyroid hormones. Hypothyroidism is when you have reduced levels of thyroid hormones in the blood, and the metabolic rate is slower than normal. So extra blood sugar would get stored as glycogen and fat. So the symptoms in this case would be lethargy, so a lack of energy. There would be weight gain. You would be sensitive to cold because you're not generating as much heat. And then muscle weakness, and then dry skin and hair. Leptin is a hormone released by cells in our adipose tissue. It acts on the hypothalamus to decrease appetite. So if our adipose tissue increases, our leptin levels will increase in the blood, which should diminish our appetite. So if the hypothalamus detects, reduced leptin levels, then it will stimulate us to feel hungry, we'll eat a meal, and then some of that fat will get stored in our adipose tissue, which then would release leptin, which would feed back on the hypothalamus to stop feeling hungry. So that's the normal loop. But sometimes cells are resistant to leptin, so that that feeling of fullness never occurs, and which will cause overeating and could lead to obesity. So the thought is that some obese people have a leptin intolerance, so they're not able to know when they should stop eating. Another hormone involved in our bodies and with homeostasis is melatonin. And melatonin is released by the pineal gland to set our circadian rhythm, so our internal body clock. So we as humans have adapted to a 24-hour clock because our day is 24 hours. And our behavioral rhythms are set to this clock. So we typically wake up around the same time, we go to bed around the same time, and then we're active in the daytime but not active at nighttime. So our melatonin levels rise in the evening and then drop again in the morning. So high levels of melatonin promote drowsiness and low levels promote alertness. Now, if you've ever gone on a long trip where there's a time change, you sometimes experience something known as jet lag. It's because our 24-hour clock is set for where we came from, and the time is different in the new spot. So it could take a few days to actually get our melatonin levels leveled off again to be used to the new time change or time zone.